Hello, good evening, good afternoon, good morning, salam alaikum, wherever you might be watching this stream. Welcome to another session on Google Cloud on the Digital Days Al-Arqam Al-Raqmiyya on MENA. Today we decided to take another topic. I think some people asking for some kind of developer-centric topics on Google Cloud. Prior to that, we covered infrastructure items. We covered networking. We covered a little bit of storage, Kubernetes. We covered security. Today, we're going to talk about applications. So for those guys who want to deploy applications in GCP, what are the options that we can have on Google Cloud? So again, for the ones who are just joined one of these sessions for the first time, my name is Nabil. I'm a GDE Cloud in the UAE. I am also director of training of Google Cloud with a company called Jellyfish in the UAE. I'm an authorized trainer on Google Cloud. So I will be sharing some exciting information about deploying applications on GCP or on Google Cloud. So Google Cloud basically provides a wide range of options to run application code, to run that deploy code. And these options can be range from things that are completely fully managed, serverless, to gives you options to cover things like on virtual machines where you have full control over your deployment code. So we will cover kind of those options, and depending on time, we will try to do some kind of demo at the end if times allows us to do that. Otherwise, I will promise you on the next session we will do some demos around those services where you can deploy code on them. So as I said, these options range from services like Dataflow, Cloud Functions, which are fully managed services. We've got other services that are App Engine, GKE, which is Google Kubernetes Engine, managed Kubernetes environment in GCP, and Compute Engine, which is basically VMs, where we want to install our applications and take full control of what we want to install, or what we want to manage. But we will be taking the overhead of managing many other bits rather than having a fully managed service that does a lot of the legwork for us. So with a Compute Engine offers us kind of an increasing ability to basically customize our execution environments. On the other hand, with the fully managed compute environments would require minimal setup and operations. The highly customizable environment like the VMs, on the other hand, require greater overhead. You will have operational management efforts to not just install the application and do all those flexible things, those kind of dependencies that you might need from the operating system perspective to the application that you want to run, but also to maintain it afterwards, to keep it running optimally with patching and with dependency upgrades that you need to manage, making sure that it doesn't break the application afterwards. So let's start off with Dataflow. So for those guys who do pipelines, who do data transformation, so they might be kind of migrating some data to take advantage of the super kind of powerful tools in GCP, like things like BigQuery, things like Bigtable, things like machine learning APIs. So they want to do some transformation of the data they bring in into Google Cloud, and for that they will need a tool that does that transformation for them. So they need some kind of pipeline, and they need to develop that code. In order to do that, we have a service called Dataflow. So Dataflow is a serverless execution engine. As I said, you can basically do those transformations to go to other services in GCP, which are from big data and machine learning. Take basically leverage those services. The runner for executing basically doing some kind of transformation in parallel with those pipelines. They work in parallel. They developed using what is called Apache Beam, and we will see what Apache Beam or Beam is stands for a little bit later. So you will need that to use that SDK, the Apache Beam SDK, and the Dataflow itself supports pipeline development by using Java and Python API. So these are the two supported programming languages that work with Apache Beam SDK, and the Dataflow then will integrate with all the cloud services for batch and streaming, and this is where Beam comes from. So B is for batch, and the EAM is from basically the part from streaming. So it is a so powerful environment that support both paradigm, the batch and stream. So with streaming, you can basically ingest data running at coming at kind of live that is streamed, that is unpredictable. You don't know when the data is going to finish. It's not like batch when you are predictable set of data that you will bring in. And for that, you can use a messaging system as a buffer in GCP, which is called PubSub. Based on basically publisher subscriber model. You can send it back with your transformation, send it to the data warehousing tool in GCP, which is for big data analytics, which is BigQuery. And then you can integrate with other machine learning APIs, all the big table tools, all the big data tools like Bigtable and more. So as I said, Apache Beam, which stands for batch and stream, taking those acronyms from there, support Java and Python SDKs to develop those pipelines. So a pipeline, basically, you can see on the right here, it consists of a data processing items. So it comprises data processing tasks that include reading input data. So you're probably doing some inputting data from external, where you will be using cloud storage as a data lake. So it doesn't matter what format this data is coming in. You just bring it to cloud storage, and then you do your pipeline transformation in GCP using the Apache Beam SDK, using, as I said, either Python or Java. So once you input your data, you do that transformation, and then you write the output data to another database or data service in GCP. So the Dataflow service uses other managed services such as Compute Engine. You can integrate it with Cloud Login natively to do some monitoring and logging for the service, Cloud Storage, BigQuery, PubSub. So Firestore API, we're talking about developer centric tools here. So it does integrate with that in order to execute those pipelines. So again, Dataflow does a fantastic job when it comes to removing overheads, operations overhead. So you don't have to need management. You don't have to scale. So it does scale automatically depending on the pipeline that you are running, the workload that you're receiving from to the service. And this is the beauty about managing and a fully managed service and a serverless service, where you don't have access to the underlying infrastructure. So you will be basically focusing on your code, trying to get the best insights out of your data to do those transformations. So with systems such as Spark and Hadoop, this is what usually developers do data pipelines with. So you will have to create a cluster, either a Spark or a Hadoop. Those users, basically, instead of focusing on the transformation itself, they will be spending significant amount of time just to try to create those clusters, tuning their jobs on that cluster. They have to estimate the number of workers, the nodes that are part of that cluster, based on that, the job that's running on the cluster. So sometimes you will find that those workloads, they're not suitable for the cluster. You need to scale it manually. So you have to stop the job, you have to shut it down, you have to add more worker nodes, reconfigure, and run that job again. So it is tedious, it is very cumbersome to manage, and it takes a long time. Efficiency, it's kind of very, very hard to achieve. So in order to run a job, it is kind of a complex task to manage that. Whereas in Dataflow, all that stuff is done automatically for you. The scaling, the reconfiguration of the underlying infrastructure is done for you automatically. You don't have to stop the jobs. It scales automatically. It runs efficiently for that. So a single configuration might not even be sufficient if you are running on your own cluster and you're managing that. So you kind of need some dynamic workload by rebalancing. And with that, we see an example here for the number of workloads that need to be when you rebalance the workload. You can see that if you don't do this dynamic rebalancing when you scale, you will find that some workers, they are finishing the job and then doing nothing, and some workers are really working hard. And this is why you will find that there isn't, you will find that this skew of the completion of the jobs for each of the nodes. When you do dynamic workload rebalancing, meaning that as you scale automatically the cluster underneath, the workloads, the data that is sent and reshuffled against those servers, it is evenly distributed, and which means that all the nodes are doing the same job. They basically working as hard as each other, which means that they will be all starting at the same time and pretty much finishing at the same time. So you won't have any skew or any inefficiencies in terms of servers running doing nothing basically. So, and with that you will be paying from cost perspective for the resources that are you using at full capacity. So you're not using, or you're not kind of over provisioning, you're not losing any resources. So in terms of costs, and it's very kind of efficient as well. And then Dataflow is ideal, like I said, for because it's we said it's Beam, it's the Beam SDK. So we're talking about here streaming and batch data pipeline. So it's great to use cases such as point of sale, segmentation analysis in retail industry, fraud detection in the financial services, IoT, and then very popular for personalized user experience in the gaming industry. So all those are very good use cases for data flow transformations, and so it is ideal for streaming and batch data pipelines. So when should we consider other compute environments rather than using Dataflow? We said that it's fully managed, it's serverless, it's completely, it takes a lot of overhead from us to do those pipeline transformation. The Dataflow SDK, as I said, is based on Apache Beam SDK. And remember, this is available in Java and Python programming languages. So if you need to do something other than Java and Python, this is where we need to execute code in another environment, because we're going to need other programming languages. So so this is where we're looking at the other services in GCP. So again, consider using Dataflow if you are relying on Apache Beam for Java and Python. And this is where comes another flexible environment, which is Cloud Functions. Cloud Functions, I would call that a function as a service. The reason I call it a function as a service, because it's not a fully fledged application. With Cloud Function, you basically you can develop an application that is event driven. What do you mean by event driven? Obviously, it's Cloud Function. It's before we go into what does event driven mean. Let's classify what Cloud Function is. So it is a serverless, fully managed, highly scalable environment as well. Each function is very lightweight microservice that enables you to integrate application components, data sources. It is ideal for microservices that require a small piece of code to quickly process data related to triggered by an event. So unless I have an event to trigger that function, and I want to run that function to do a particular task, and then once that task is done, that function is doing nothing. So the example that we see here in this slide, all components of the application use a fully managed service and APIs. So we've got, you can see here, we're using cloud storage, we're using PubSub, we're using Cloud Functions, the Vision API. So we're bringing in the capabilities of the pre-trained machine learning APIs in GCP with Vision API, the translation API, and then cloud storage is a service that, as I said, is a data lake. So you can put whatever data you want to put in there. So these services scale. Obviously, all those that we see in here scale automatically, depending on the volume of incoming data, and they do require compute resources that are fully managed for us. So this scalability and reliability enables you to focus on the application code. So as a developer, we love an architecture like this, because they don't have to worry about the hardware, they don't have to worry about maintaining the infrastructure that run that code. And this is what is so powerful about the cloud function. So let me just briefly explain what this kind of architecture is doing. So here, what we want to do is we bring in images to cloud storage. Cloud storage is a service in GCP that has a functionality, what is called notification. So if an image hits, you save and you bring in an image to cloud function, you can bring in a notification. That notification can be the event to trigger a cloud function. This cloud function basically will call up on the Vision API to basically read, to do an OCR function, to read things like logos, to read text that is written on images. So once that text is written, we can send it as a message to another messaging system, which is pops up. So we create a translation topic in there, and that message will be sent to call upon another cloud function to do the translation. So it will call up on the cloud transformation API, and then once it does the translation, it will basically send it to another PubSub. It will write it. It will call up on the cloud storage again, another cloud functions that's gonna write that text to a bucket in cloud storage. So imagine that you have maybe hundreds of thousands of those images that's got text in them in a different language, and you need to translate it. This is the architecture to be able to do that, bringing in all those capabilities of machine learning, pre-trained models, and the APIs that allows you to extract the text from the image, do the translation with the cloud transformation API, and then write it out to another storage bucket. So now you've got a fully translated text from images in this kind of architecture that we see here. So cloud function can be used in a variety of use cases. We already seen it just working out with different APIs in there. So you can use it for lightweight, very simple, like we've seen in that message to translate to do that transformation. So not like Dataflow, where you can bring in petabyte size data to do transformation of that data to look after the different schemas and things like that. This is just for a lightweight ETL, extract, transform, and load. So you can bring from, let's say we've seen in the previous example, bringing it to cloud storage as an image, take out the message, and then do that transformation, translation, and send it back to another cloud storage bucket, or you can send it to, let's say, BigQuery or whatever. So so we do that transformation messages that are published to the PubSub. They can also serve as a target for webhooks. So webhooks are another kind of a trigger for cloud functions. So they are basically, they make those HTTP calls to invoke a particular function that is implemented to do whatever task. For example, we've got something in GCP called billing notification. So you can set billing alerts based on some budget. So let's say you set a budget for your project that you work in GCP, and to be sending you, when you reach, for example, 50% of spend from your budget that you specified, to send you a notification. So that notification can be a webhook to do something programmatically. Let's say you want to stop a virtual machine or to stop a complete environment. You can do that programmatically based on that notification that you get from that webhook that you set up. So basically, any lightweight functionality that is run in response to an event is a candidate for cloud function. So you just pay for the time that the cloud function is running, something that you require just to trigger a function that runs for to do that particular task. So you don't need a fully fledged application that runs for 24 hours and paying for those resources running all the time. So exactly what is similar to Dataflow, cloud function allows you to focus on your code infrastructure that is running completely taken care for you by the service. So here, for example, we've got a Node.js example code. When using Node.js runtime, your function source code must be exported to a Node.js module. You do not need to upload any zip files with package dependencies. You can specify any dependencies for your Node.js cloud function in a package, like you see on the right hand is a package.json, so a JSON file. And basically the cloud function service automatically will install those dependencies before running your code. So you don't have to worry about that at all, which is very, very kind of useful, super useful for developers. So you can use also a set of cloud client libraries to, if you want to programmatically interact with other cloud services as well. That's also possible. You've got all the documentation for that, and you can integrate it with that. So what are the programming languages that's supported with Cloud Functions? This is another one, more obviously than Dataflow. So you've got Node.js, like we've seen here, is supported. Python is supported. Java and Go, is also supported. So those 4 languages are supported on Cloud Functions. So again, we need to look at different environments. So when is it a Cloud Function not suitable for my use cases? So we should be considering using other compute environments to run our application or microservice if we have a very large complex code base. So Cloud Functions is for small functions that run those event-driven tasks that we want to run. So if you need to use languages other than Node.js, Python, Go, or Java, and you need like large complex code base, this is where you want to be looking at other things other than Cloud Functions. And this is where the App Engine flexible environment comes into play. It gives you more flexibility, obviously. Flexible comes from flexibility. So let's see what can we do with App Engine flexible. So App Engine flexible environment, it's an environment obviously to deploy web applications at scale. It could be for backends of mobile applications. It works on HTTP. You've got internal business applications also. They very, very good at that. It provides you some kind of default settings for the infrastructure component. So you can customize things like the network that you want to deploy your application to, the sub network. Those are the things that we talked about when we covered the networking session. So please refer back to YouTube videos for those sessions if you want to understand how networking is done on GCP. We had a session titled if you do demystifying Google Cloud networking, you will find it, and we will talk about all those things, subnets and networks and ports and firewalls and instance tags and all those kind of things. You can basically customize with the App Engine flexible environment. You can SSH. You've got SSH access to the VM instance in the flexible environment if you want to access your VM that's running your App Engine instance. Obviously, it is disabled by default. You can enable root access to the underlying VM instances as well, and basically it is a containerized kind of environment. So you run Docker image for your application. If needed, you can generate the Docker image of the application and run it in other container-based environments like GKE, but the flexible environment gives you that option to run your Docker image application. What does it support? Obviously, more runtimes than Dataflow and Cloud Functions. So I don't memorize all the environments. So let me see here the list. So we've got Java 8, we've got Python 2.7 and 3.7, Node.js, Ruby, we've got PHP, we've got the .NET Core, we've got Go, and there are other runtimes also based on custom Docker image or open source stock of file. You can use also with that. You can use client libraries, the cloud client libraries, to programmatically interact with other cloud services in GCP as well. So as you can see, we're moving towards more flexibility in terms of runtime for the services. We started with Dataflow, which supports just Python and Java because it's the Beam SDK, and then moved on into Cloud Functions, which supported another 4 environment runtimes, and now we've got about 8 that are supported, and it's open for more upgrades in the future as well. So you can see that's a typical architecture of microservices with App Engine. So you can use App Engine flexible environment to basically get started with microservice architecture like the one that we've seen here. The application that we see here, it's basically deploys. We've got a front-end service and a back-end service that are completely loosely coupled, and this is what the benefits of the microservices paradigm. So you want to loosely couple all your microservices, and this is exactly what this architecture is giving us. And you've got like a pub sub messaging system in between to manage that communication, sending messages to from front end to the back end. So you can go from code to production with a single command. As I said, depending, I'm just looking at the time. Depending on the time, we might do a demo at the end, but we see how it goes. But basically, with a single command, with cloud, with App Engine Flexible or App Engine Standard that we're going to talk a little bit later. So after you develop your application, you've got your Docker image ready. You can deploy to your test staging to the production environment with a single command. You just need to run gcloud app deploy, and you're pretty much done. When you run this command, App Engine Flexible Environment automatically will upload your source code to cloud storage. It will build the Docker image for your application with the runtime environment that you specified, and then it will push the image to the container registry within GCP. So you don't need to set up any Docker scripts for applications that use one of the App Engine's native runtime environments. So behind the scenes, there are all things that happen. So behind the scenes, also App Engine will set up the load balancer that runs your application, because you need to load balance your basically load that is coming to the application, and runs your applications in one region. We talked about region before. Is basically a location, a city, a geographical area where there is 3 zones at least. With zones are data centers, so it will load balance across 3 zones to ensure that your application is always end up running. So if one instance of a data center goes down or something happened in one zone, you can always send traffic to the other zones, the other data centers. So high availability, highly resilient, and basically the App Engine launches and auto scales the compute engine instances to run your application, and it will ensure that your application can scale up or down depending on the traffic volume that is coming. So it is very, very efficient in that as well. Obviously, it doesn't scale down to 0. It will scale to a certain level. You need to run one instance to be running at least for the service. For the flexible App Engine flexible environment. It also sets up other services that are crucial for application. So you've got the monitoring, the management, the logging, the error reporting, natively integrated with that, the health checks, any SSL certificates, all that is fully managed for that. So what it's given us here an environment where we can quickly deploy our applications without manual infrastructure setup. It automatically apply critical or any upgrades. It will take care of the any compatible backward compatibility with previous versions as well, because we're doing some always security updates to the underlying operating system. So if you need more control, you can directly SSH to the VM instance that is running to work with more of the custom runtime. So if you need more of those that we mentioned, you can by all means install all the runtimes that run your application. So the other very, very powerful feature of App Engine is deployment without downtime. So if you have a new version of your application, you can deploy that new version, second version of your application with zero downtime. And the way it works is basically doing traffic splitting. So App Engine flexible environment enables you to perform what is called canary testing. So you can verify a production release before serving any external traffic. So you can start with a small portion of your users to be using the new version of your application. Let's say you've got application version A, version B. So let's say you can set the traffic to 5% of the traffic to go to the new version. If you're happy with the deployment, then you can set all the traffic to go to that new version, or you can basically roll back if you need to send that traffic back to to the previous version if there is any issues that came up during the release of to the production. So rollouts and rollbacks, very, very flexible. You can do that. You can perform A/B testing for your application, deploy these updates by using this feature of traffic splitting between current version and the new version. And after you verify that the new version works, you can migrate all the traffic to the new version without any downtime. So what is the ideal for? So just to see, to be able to define what are the limitation of that, where is the App Engine flexible environment good for us? Obviously, it's ideal for highly scalable web-focused applications. This is what it is used for. So you can use the App Engine. You can use the App Engine flexible environment for anything that is HTTP, HTTPS, so those kind of things that you use it for. So anything that use HTTP, HTTPS request responses, applications that deploy public endpoints. This is where you have to send your user to an endpoint. This is App Engine is good at that. So you can also implement CI/CD pipelines that uses things like Jenkins. And Spinnaker to deploy applications to apps. So fully integrated with that, and this is why developers they love it in terms of these use cases. So it makes life a lot easier for them. So they will basically focus, as we know, developers just like give me some code to write kind of thing. So I don't care about the setting up a VM while I run it. All right. So when do we consider other compute environments? Like we've seen, we're moving towards more of services that have more customization. So we moved from, again, to summarize, we moved from Dataflow with two supporting programming languages, and then we moved on into, and we looked at Cloud Functions. Then we're looking at the App Engine flexible environment. So when are we not using that? So we consider using that if we're not using HTTP, HTTPS basically. So if any other protocols other than the HTTP, HTTPS, we should be looking at something else, either maybe GKE, Kubernetes environment, maybe a full VM that we are in control, or we also have what is called Cloud Run. We're going to look at a Cloud Run, how it differs to that. So with App Engine, you can't write data to disks, to persistent disk with the App Engine. App Engine flexible environment enables you to add some volumes to the temp.fs, and these files are in memory only, so they don't persist. So if you shut it down, you lose that data. So it's like a scratch storage basically. So at the current time, App Engine flexible environment is not ideal for very low traffic or anything that is spiky, that scales up and down very quickly. And basically at least 2 instances are running at all the time to serve traffic. So as I said earlier, it doesn't scale down to 0. The minimum that runs underneath is two instances to be ready all the time to serve traffic coming from users for that. There is another version of App Engine, which is the App Engine standard. Usually what I do, I cover the standard first, and then for flexibility, I move to the other one. I'm doing it the other way around here for some reason. And App Engine, as I said, there is another flavor of that called the App Engine standard environment. So if you do have applications that have a spiky or a very low traffic, this is the reason why we would want to use App Engine standard environments. Maybe an option for you if you have those requirements there. So App Engine applications that are on the App Engine standard must use the App Engine standard API to start with, and the App Engine standard API are supported only on the standard environment. So you can't mix and match the two environments here. So if you built an App Engine using App Engine standard API, you cannot run it in any other environment, such as the flexible environment or GKE or Compute Engine, because the underlying infrastructure is completely different. You're not running VMs. The underlying infrastructure is completely like a sandbox that you don't have any control over. The applications that are developed using the cloud client libraries can be moved to another compute environment like Cloud Function, GKE, or Compute Engine, if the needs of the application changes as well. So this is kind of like a bit of a difference between the two. And the other thing is with, as I said, because the underlying environment is not the same, the App Engine standard will basically scale down to 0. So it's not like the flexible environments where you have VMs that you can access, you can SSH to. App Engine standard is completely different. It's a sandbox that is have a lot of constraint, and it does scale down to 0. So if you have an application that is not serving any traffic, it just basically hibernates. We're not using any services, and you basically would be paying 0. So you're not paying any for those resources that are running your environment. Okay, Kubernetes Engine, a topic that came over and over for many of the sessions in the MENA digital days. It's another environment that's where we can run and deploy our applications. So what is Kubernetes? Just as a refresher, if you attended one of those sessions before, it is an open source deploying platform for containers, basically. So it is an orchestrator that manages deploying containers for us. And the idea behind it is that Google, for a long time, basically Google, they run everything on containers. They were the first kind of organization that it's a Google technology. Basically, they were doing everything on containers. Google ran their containers on an operating system called Borg, which is that the startup where Kubernetes came from, basically. So if you have a large scale of applications, microservices, this is where you would looking at an orchestration tool to manage that for you. Just to put it in perspective, just to give you an idea, years ago, maybe in 2015, something like that, Google were running at that time, it must be 10-folds or 100-folds more than now. They were running in the range of 2 billion containers a week, which equates to around 3,500 containers a second, which is huge. And for that reason, Google came up with Kubernetes, or their operating system Borg, to be able to manage that scale of containers for them. So it was first developed at Google, is now a cloud native computing foundation project with a very large active community. So it's the go-to environment to run containers. It provides you with basically with kind of framework to run and orchestrate your containers in a resilient fashion. Scaling, it takes care of a lot of overhead from management, such as scaling your application components, providing that network connectivity between the containers, so stable network abstractions, failovers, rolling out deployment, storage orchestration, the management of secrets and configuration, all those kind of things. It does be taken care of by the Kubernetes. What does Kubernetes consist of? A Kubernetes cluster contain what is called a control plane. A control plane will have a few components. So the major ones that we can see here, the Kube API server that allows the master node to talk with the external API, so to receive those commands from the user externally and send that to the nodes in the cluster. You've got the Kube controller manager, the Kube scheduler, and other components that are kind of the brain of the master node. And this is what GKE will do for you. It will manage the control plane for you, so you don't have access to it. It's completely hidden from us and kind of abstracted away from us, and it's fully managed by Google for us. The nodes in the clusters, basically, they are virtual machines. So basically, that they run the application, and the Kubernetes control plane will manage those servers, those worker nodes, and basically you can deploy what is called pods. Pods basically is the smallest object that you can deploy to Kubernetes, and the pods will contain those containers. So a pod is a group of containers that will be sharing networking, that will be sharing storage, and basically will be having your applications running on them. And on the node, you would have what is called the kubelet, which is like a proxy kind of an agent that will allow you to have that communication between the control plane and the node. And the kube proxy, basically what looks after the networking communication between the nodes and between the cluster master. Okay, so as I said, GK is the managed Kubernetes service on the in Google Cloud. It helps you to deploy, manage, and scale the Kubernetes environments for your containerized applications on Google Cloud. And basically, more specifically, GK is a component of the Google Cloud Compute offerings that we can deploy our applications, containerized applications to. So it makes it easy to bring in Kubernetes workload into the cloud. So if you have on-prem, you are using Kubernetes, you can bring it as is and use GKE to manage that Kubernetes cluster for you. Anything that is you would expect from managed service, the upgrades, the patching, the security, the monitoring and logging, all is being taken care for us by the GKE service. So what are the features that we get with that? So the GKE, as I said, is a fully managed, which means that you don't have to provision any underlying resources. Now, things like the cloud data flow, the App Engine standard, the cloud functions, those are specifically the cloud functions and the data flow. These are completely fully managed and they're completely serverless, which means we don't have access to the underlying infrastructure. App Engine flexible. A little bit, I can access the I can SSH to the VMs that are running. So we have at least 2 instances running. The standard is completely serverless, so I don't have access to the underlying infrastructure. GKE is kind of hybrid in terms when we talk about kind of it's fully managed, but it's hybrid in terms of calling it a serverless service. It's not a fully serverless service, and the reason behind it, like I said, the master node where the brain of Kubernetes is happening is completely hidden from us. It's managed by Google, and we have access just to the nodes, so we can basically specify what kind of CPU and RAM I can run on those nodes. If I want to auto scale, for example, I've got functionality to do that, and this is why it sits in between kind of compute engine instances, which are VMs, and the App Engine flexible environment and App Engine standard in terms of management. So as I said, it does use container optimized operating system to run our workloads, and all those operating systems that are fully managed by Google. They are optimized to scale quickly with minimal resource footprint. And when you use GKE, you start by directing the service to basically create a cluster for you that is Kubernetes based, and the system is basically this cluster will have auto upgrade features, so you can enable that as well. So auto upgrade depending on the workload, so you can add more nodes basically if you need to, ensuring that the cluster are always automatically upgraded with the latest stable version of Kubernetes. Sorry, auto upgrades feature is for upgrading the operating system. Auto scaling, it's adding more nodes to the cluster if we need to. The virtual machine that hosts your containers in GKE clusters are called, as I said, nodes. They do have auto repair, which basically can repair in healthy nodes. So if for whatever reason the one of the nodes or those VMs becomes unhealthy, it makes periodic health checks on each of the nodes of the cluster. And if any node is determined to be unhealthy and it requires repairs, what happens in the back end as a managed service, GKE will basically drain the node of any workloads of any pods that are running. It will migrate them to other nodes, and it will gracefully exit that node and it will shut it down. It will then recreate the node for you, just as Kubernetes supports scaling workloads, it supports scaling of the cluster itself as well. We can integrate it obviously to cloud build to deploy application, to container registry, to any Git repositories as well. This allows you to automate your deployment using private container images if you need to, that you have securely stored in a Git repository or a container registry. From security perspective, obviously, It does integrate with logging and monitoring natively. So all the logs and monitoring happens for you with the default dashboards and things like that. So you can basically track and understand your application performance and behavior. It integrates with networking with VPC. So you can specify which network I'm using for my Kubernetes with a lot of features from for networking that is with GKE, and also integrates with Cloud IAM, Cloud Identity and Access Management. And in that case, I might be able to, I might want to basically specify who have access to my cluster, to my nodes, to my workloads. So there are different features specifically to Kubernetes Engine to from security perspective of how to use those RBAC, for example, role-based access control. And from the cluster perspective, we got GKE predefined roles as well. We might have in a future session just to focus on those security of GKE, which is, I think, very, very interesting topic to be covering. And finally, the Cloud Console provide you insights into the GKE cluster with the resources, allow you to view, to create the cluster itself, delete resources, and many other things from the Cloud Console. What are the things that I can support with GKE? So GKE supports any runtime that you can package as a Docker image, because it's Kubernetes at the end of the day. It's ideally suited for any kind of microservices application at a large scale, so any containerized applications, including any third-party containerized software as well. So you can run your container image on the Kubernetes in a hybrid cloud or multi-cloud, because it's an open source. So you are never locked in to Google Cloud. So you can take your workload, run them in any other Kubernetes, as long as it's Kubernetes based, then should be absolutely fine. And this is especially helpful when you have some parts of your application running on premises and other parts in the cloud. So it's like a hybrid model that's also possible. So you can have and this is what is something covered with a product called Anthos, which is based on GKE. So yeah, you can have the hybrid connectivity as well. You can also use GKE to run containerized applications that use network protocols other than HTTP and HTTPS, not like the App Engine flexible environments. So what does that give you? Managing the infrastructure for Kubernetes can be very complex. So it will take all that overhead from you, the network, the load balancers, the storage, the integration with the Google Cloud Operation Suite. So that's the logging and monitoring. So all those kind of stuff is completely taken care of for us as a managed service. So it makes it easy to run, to deploy and scale clusters. So you can, when you create a cluster, is as simple as running from the Cloud Shell, a G-Cloud containers cluster create, and you will specify if you wanted the machine type of the nodes, the number of nodes, the disk size. You can enable auto scaling if you wanted to. So you've got a lot of kind of customization that you can do, or you can simply run G-Cloud containers cluster create and give it just a name, and you will go with the default, which is basically you will be creating a cluster with 3 nodes with the standard VMs, and basically you can auto scale that afterwards. Deploying applications. I think the power of Kubernetes also goes to basically deploying environment as code. So not doing that in scripting or creating by command, but rather creating what is called a YAML manifest file. So inside your GKE cluster, you deploy and manage your containerized application in exactly the same way as you would with any other Kubernetes environment. Most of the operational tasks are carried out using kubectl. So the kubectl, with the kubectl command, I can create any Kubernetes object. But the power of Kubernetes, as I said, is to be using a declarative environment. So you can specify the environment in Kubernetes that you want. So in this case here, you can see I've got the name of that deployment that I want to run, how many replicas I want to run, how many pods I want to run, the image that I want to run, how to access it, which port, and basically kubectl create or apply that file, and it will create that environment for me. So any kind of replicas that are happening or multiple environments, multiple deployments that create from a YAML file, they will be happening in parallel. If I use kubectl, I have to run it in successive, so one after the other. So and in that case, with deployment, for example, you have more control over the replicas. So if one pod goes down, the replica set will basically is a controller that always checks the health of the pods. So if one goes down, it will look at how many replicas I wanted from the desired state of my environment, and it will say, okay, I've got 2 running, 1 is down, I need to bring another one out. So it is so powerful in terms of that. And the second thing, you can deploy the same configuration in different environments exactly the same way. So you just change, you can run it in a different cluster, and that's very, very quickly to create identical environments easily and very cheaply because you're running it on the same cluster, maybe in different pools. And that will allow you to probably create what is called like a test pre-prod QA in a prod environment in exactly very, very identical. It also have a third benefit when it comes to disaster recovery. So if your environment has shut down, or you deployed something and somebody deleted accidentally so your environment, those YAML files, you can just run kubectl create, you bring that file again, and your environment is there in seconds rather than minutes or more than that, or hours for some instances. So as part of continuous integration and delivery CI/CD pipeline, you can generate Docker images for each code commit and automatically deploy the image to development. So you've got the code, build, the deploy. You can store artifacts in the container registry. So it's very, very easy to do a CI/CD pipeline to deploy to the Kubernetes engine. So if your application cannot be packaged in a container, so we're not ready, for example, to run our applications microservices. So I do have like a monolith application. This is where GK is not kind of a requirement. So GK is not suitable for monolith application. I can run one application in a big container, but that's not the use case for it. So if your application cannot be containerized, I can run it on Docker, for example. This is where we should be looking at something else. And this is what brings us to Cloud Run and Compute Engine. So with the Cloud Run, it's a managed compute platform that enables you to run, and I will put double line under this, stateless containers. So before moving into how to run applications that are not suitable for containers, Cloud Run is another environment that is based on Knative, which means that Knative is built up above Kubernetes. So Knative is basically in an environment that is fully managed for us. I don't have to worry about the underlying infrastructure. I don't have to create a cluster like GKE. So I will be just focusing on developing applications. As long as the container runs on Knative, then it should be absolutely fine. And developers, they similar to App Engine Flexible and other environments that are serverless. Cloud Run is another serverless service that I can run stateless containers on, invocable via web requests or pub/sub events messaging. It is a serverless. It abstracts away all the infrastructure management, so I don't have to worry about that. It's built in, like I said, on Knative, and gives you the choice of running your containers either fully managed with Cloud Run or in your own GKE cluster with Cloud Run. So there is a Cloud Run version that runs on GKE, so I can run stateless containers on there as well. It doesn't restrict your code, so you've got many runtimes, Python, Go, PHP, Ruby, Java, many kind of flexibility in that case. The main point here that you take our point here is stateless containers. And it does any stateless containers that listens to requests or events delivered via HTTP. So those containers offer flexibility, portability of workload. So as long as I've got a Knative environment, I can take my workload and run it not just in GCP, or not Cloud Run, any Knative environment framework, basically. And again, so it does let you just to focus on code and deploy your code. So you're not running any underlying infrastructure patching, auto scaling based on the workload, on the demand. It will scale for you automatically. Deploying is as simple as gcloud beta run deploy. You specify the image, platform manage, and you're pretty much done. So you deploy the application in that way, and Cloud Run horizontally scales your container image automatically in order to handle received requests, then scales down when demand decreases. So you only pay for the CPU, memory, and the networking consumed during the requests that are handling based on those requests. So again, so when do we need to consider things other than Cloud Run and GKE and other services? So when the application basically is not suitable for containers, cannot be packaged as a container, if your application is not stateless, or must respond to requests or events delivered using protocols other than HTTP, then GKE or Cloud Run would not be suitable. So if you need to access the network or need to deploy the containers to custom machine types, this is where we want to consider Cloud Run GKE. Other than that, anything that is not a stateless container, I can't run it on Cloud Run. Moving on to GKE, if I can't have my application in a container, this is where I want to consider Compute Engine. So I will have my virtual machine. I am in full control, basically. So you can run your application on different types of VMs. So Google has got a very wide range of flexibility in terms of what kind of VMs I can have. You have predefined, you have custom machines, you can have a big selection when it comes to CPU and memory. From persistent storage, you've got SSDs, you've got HDDs, you've got something in between from performance perspective between HDDs and SSDs. So it gives you flexibility between in terms of performance and cost. You've got preemptible VMs as well. So preemptible VMs are basically virtual machines in GCP that gives you 80% discount, but they have no SLA. They're not guaranteed over 24 hours, and you can run any operating system you want. So you can bring your own image. You can run it. You can bring your own license if you've got an operating system that is licensed already. But you've got a very wide range of operating system that you can choose from, and you can also use a shared image from the Google Cloud community, or bring your own image from your on-prem with different application. I think the best practice when it comes to images is you use your custom image. So you might have like a front-end application that needs to run a specific application. So you package the application with the operating system, and you use that image as part of the VM for the front-end application. You might have a database backend, so you need to install SQL or Oracle or whatever as part of the image. So the last thing that you want is to bring in an image and then install software on top of that for many servers. So best practice is to use the software that you want to install as part of the image when you create those VMs. So basically, you have full control of the infrastructure, machine type, and OS, the software that you want to do, and also you've got flexibility. So you've got what is called managed instance groups, which we talked about in the previous session, based on an instance template to basically configure global load balancers, which allow you to those instance group to sit behind the load balancer to auto scale. So and the compute engine can perform health checks. You will be able to replace unhealthy instances in that instance group. It will auto scale based on load balancer traffic or metrics like CPU, or any custom metrics that you can bring in from logging and monitoring. So as long as you do some monitoring of that instance group with those VMs, you can specify some kind of specific custom metrics that will be the basis of scaling that instance group to deal with more traffic coming in into your front-end applications that sits behind that load balancer. And you have obviously complete flexibility in terms of what kind of CPUs or GPUs or TPUs, if I'm using things like TensorFlow, machine learning intensive algorithms, third-party software. So obviously I am in control of that. But with that, it comes the overhead of management. So I need to manage all that. I need to manage the patching, the security, all those kind of stuff. And this is why they are suitable for lift and shift migration. So if you have an application that is running on-prem and don't want to change anything, then I can bring as is the VMs that are on-prem to GCP. And there is a tool in GCP that helps you to do that, migrate for Compute Engine. So it will basically automate the whole process for you. You just click the button and it will basically migrate those VMs into. There is obviously some pre-configuration that you need to do. Maybe one of the future sessions we need to look at how do we migrate from on-prem to GCP. So that would be a good session to do. So I will make a note to be doing that in the future to see how that works. So obviously with that flexibility, as I said, it's not like when we have containers. So containers, you can run them wherever they want. And as soon as you deploy them, your application is running. On the VMs, you need to consider that when you start up a VM, it will take at least 60 seconds to spin up a VM. And then you have to instantiate your application on top of that. You might have some startup scripts that are running. So especially if you are running some custom images. So always consider that startup time when you're using VMs, because it does take time to have your application fully running. So to ensure that your VM always starts or launches very quickly, try to use startup scripts to identify and correct steps that can take a long time to complete afterwards. So do it as part of the boot. So if you are downloading and installing a lot of software, consider using custom images. Like I said, it doesn't make sense that you have a Windows operating system and after the VM comes up, then you would be thinking about installing those software. So make the software as part of the image when you create those VMs. So to summarize, I think we hit over an hour now. So to summarize, Google Cloud provides a range of options to run your application code. So we looked at Dataflow, we looked at Cloud Functions, Cloud Run. Those are fully managed. We also looked at App Engine, GKE, and Compute Engine, which offer steadily increasing abilities to customize your environment. Fully managed compute environment requires minimum setup of and operations. On the other hand, highly customizable environment will require, like the VMs, will require greater operations and management efforts. So you will have to look after the management of those VMs afterwards, make sure that they are running healthy all the time, patching, security, to keep the application running as optimal as possible as you would like it to be. Now, that you know the ideal use cases for each execution environment, you can choose the compute environment that matches the needs of your application and the needs of basically your expertise into those runtimes. So, for example, we covered Dataflow. If you're not familiar with Java and Python, obviously you're not ready to use Dataflow. You need to have a look at something else. So it's all based on the requirement that you have and basically your expertise and your skill set that you have in order to run those applications. I think unfortunately we don't have time to run any demos, but I will promise to do some demos in the future, either as part of another session or we can do what is called study jams. So study jams will allow us to have those sessions to have practice. So introduction to a topic, and you will be having access to labs. So watch this space. We will be introducing those study jams in the very near future. So keep basically make sure that you join the MENA GDG groups and look up for those advertising for those sessions that are coming in the near future. And with that, let me see if there's any questions. Even if they are in Arabic, I can take those as well. And I can't see anything there. I think the team have shared my link in there. If you want to reach out, you have any questions, by all means, you can reach out to me on my link in there on Twitter or whatever. So again, thank you very much for your patience with us today, and hopefully you find it useful. You learned something today, and I'm looking forward to seeing you in future sessions. Keep looking for those study jump sessions that are coming in the very near future, so you will have practice with the Google Cloud technology. Thank you very much, and have a very good evening. Assalamu alaikum.